So, in the third example, we are considering this compound 1,1-dibromo ethane, or it is called ethylene dibromide. Here two non-equivalent set of the protons are present, so two peaks will be given by this compound in the NMR spectrum, and out of these two peaks, these three protons are represented by A protons. This one proton is represented by B protons. First, we consider the peak of the CH3. Peak of the CH3 will be split up into two lines according to n+1 rule. On the adjacent carbon atom, one proton is present, n is equal to 1. So n+1 is equal to 2. So CH3 signal or CH3 peak will be split up into two, and how doublet is obtained, this will be the arrangement. One proton has the arrangement nuclear magnetic moment in this direction, other has the direction in this direction. So two lines will be obtained for what? CH3 protons, and the ratio will be 1 to 1. How doublet is obtained in the NMR spectrum? This is the doublet. Now you have seen earlier that arrangement of the nuclear magnetic moment will give the doublet, and this is diagram how doublet is obtained. One line in the doublet has lower delta value, another line in the another line in the NMR spectrum has greater delta value, so these two are separated, but the intensity or the height of these two lines are equal, so 1 to 1 ratio is present in their intensities. Now we consider the B type of the protons, that is the one proton of the CH. It will give one peak, and in how many lines it will be split? It has three protons on the non-equivalent protons on the adjacent carbon atom, so n is equal to 3, and n+1 number of lines in this split peak will be equal to n+1, so 3 + 1 is equal to quartet. It will peak of the CH will be split up into quartet. How it will be split up into quartet? What will be the arrangements? These are the arrangements. Three protons have this arrangement, this arrangement, these arrangement we have already discussed, these arrangement we have already discussed, these arrangement we have already discussed. This is external magnetic field. So this arrangement has highest delta value, then this arrangement has lower delta value as compared to this one, this has further lower value as compared to first and second, this has lowest delta value. So four different lines are produced in the quartet of the signal CH in the CH3CHBr2. Now this quartet is explained on the basis of the arrangement of the nuclear magnetic moment, and here in the NMR spectrum this type of the quartet is obtained. This is 1 ratio, how much? This one 3. 1, 2, 3, 1, 2, 3. 1 ratio 3 ratio 3 ratio 1. So you can see the height of this peak and this peak is 1/3 of these peaks, these two peaks. And the height of these two peaks is 3 times greater than that of this peak. So 1 ratio 3 ratio 3 ratio 1 height or intensity of this peak can also be explained in the form of the NMR spectrum. So this is the basis of the NMR spectrum, spin-spin splitting or spin-spin coupling, and how spin-spin splitting will give the different lines in the split peak, and how many doublet or triplet or quartet etc. that can be explained on the basis of spin-spin interaction of the protons on the adjacent protons of the adjacent carbon atoms, and their ratio can also be explained. I have told you that how we can differentiate the doublet, that is two lines of the same peak or signal, from two independent peaks or two signals. One is that the difference between the spacing between these two will be if 0 to 100 0 to 18 Hz, then it will be splitting. If it is greater than that of 18 Hz, that will be two independent peaks. Second very important point is it is not affected by the external by increasing or decreasing the external magnetic field. Third thing is that the splitting has a specific ratio of the height or intensities, while no specific height ratio or intensity ratio is present in the doublet of in the two independent signals, or three independent signals, or four independent signals. Now intensity can be explained on the basis of the Pascal triangle. Peak area or height of the peaks or intensity of the peaks, here you can see, if you are writing, it is in the form of a triangle. This constitute a triangle. This is called as Pascal triangle. Now in each entry is a sum of the values immediately above it to the left and right. Here you can see, if a single peak is present, this is printed as 1. If a doublet is present, its height will be decreased as compared to the singlet, and it will be divided into 2, and here there is no digit below 1, and these 1 are separated separately. It will give 1 ratio 1, that is doublet. Now here 1 is written here, 1 is written here, and these two are added together. 1 plus 1, it is written here, 2. So in the triplet, the ratio of the intensity will be 1 ratio 2 ratio 1. Now we come here, 1 is written here, this 1 is written here, 2 plus 1 is written here, 2 plus 1 is equal to 3, it is written here, 2 plus 1 is written here. So this is what 1, 2, 3, 4 in a quartet. The ratio of the intensities ratio of the heights of the peak, ratio of the areas of the peak will be 1:3, ratio 3, ratio 1. Always will be this ratio. Now 1 is extended on this side, 1 is extended on this side. 3 plus 1 is equal to 4. 3 plus 3 is equal to 6. 3 plus 1 is equal to 4. So how many lines are present in this split peak? 1, 2, 3, 4, 5. It will be quintet or pentate. Quintet or pentate. What will be the ratio? Ratio of the intensity or ratio of the heights or ratio of the area of the peak. 1:4, ratio 4, ratio 1. Now in the next example, 1 is extended on this side, this one is taken on the external side. 4 plus 1 is equal to 5. 6 plus 10 is equal to 10. 6 plus 4 is equal to 10. This 6 and 4 is equal to 10. This is 10. 1 plus 4 is equal to 5. 1:5, ratio 10, ratio 10, ratio 5, ratio 1. 1, 2, 3, 4, 5 and 6. One, two, three, 4, 5 and 6. 1, 2, 3, 4, 5 and 6. This is the how many lines of this signal will be present? 6. And the ratio of intensity will be 1:5, ratio 10, ratio 10, ratio 5, ratio 1. So height of the side one will be equal to 1. Then the adjacent will be 5 times greater than that of this one. Then the other will have 10 times greater than that of first one. So this ratio is present in the sextet. Similarly, you can predict for septet, octet and nonet. You can extend this one here. This one will be extended here. Then 5 plus 1, 6 will be written here. 10 plus 5 is 15 is written here. 10 plus 10, 20 is written here. 10 plus 5 is written here. 5 plus 1 is 6 is written here. So in this way you can predict how many lines will be present in split peak. Here it is sextet, then in the second then in the next it will be septet. And their intensities can also be very easily explained by the use of the Pascal triangle. You can see some examples here. How many equivalent set of protons are present in this compound? 2 equivalent set. CH3, 6 protons are of one equivalent set, 1 protons are of another equivalent set. The peak of this CH proton will split up into how much? N is equal to 6. N plus 1, 6 plus 1. So it will be what? Septet. Septet will be the number of peaks in the CH signal or CH protons. Septet, 7 lines. And for these CH3 protons, there will be a doublet because these are equivalent protons and the non-equivalent proton is hydrogen. One will be added n+1, so doublet will be obtained for the peak of CH3 will be split up into two. You can see another example. This is the 2-butanone. 2-butanone. How many set of the protons or non-equivalent set of the protons are present? This is 1, this is 2, this is 3. 3 non-equivalent set of the protons are present in the 2-butanone. So now we see the splitting of the CH3 protons. Since there are present no protons on the adjacent carbon atoms, so it will give a singlet peak. Its peak will not be split up. Now we consider B protons. B protons have 3 protons on the adjacent carbon atom. So n is equal to 3, and the peak or the resonance of the CH2 proton or B proton will be split up into the quartet peak. Now we see the splitting pattern of the CH3 protons. CH3 proton on adjacent carbon has n is equal to 2. So the number of the split lines will be n+1 is equal to 2 plus 1 is equal to 3. That will be triplet. And in the triplet, what will be the ratio? This one. 1:2:1 in the triplet. 1:2:1 in the triplet. And what about this is the triplet for CH3 protons, and for CH2 proton it will be quartet. N is equal to 3 and n+1 is equal to 4. So B protons or CH2 protons will give quartet peak, quartet split peak, and the ratio of the heights of the quartet will be 1:3:3:1 for the quartet peak, quartet split peak. So I think you will be able to understand the basis of splitting, how relative ratios of the intensities of the peak or the height of the peaks or area of the peaks can be explained on the basis of the spin-spin interaction or spin-spin coupling. Inshallah, next time we will study some more topics. For the time being, it is, I think, will be quite clear for you. If you have any questions, you can ask me. Any confusion, any question, you can ask me. Okay then. Khuda Hafiz.